Hello 108 students, Mr. McCue here. Welcome to section 9.7. We are continuing on page 5 and we are going to work on objective number 3, and this section here is going to introduce us to cubic polynomials, and this is an introduction, and the polynomial will have a degree of 3, but the textbook is simply going to help us out and give us 3 sets of parentheses multiplied together with an inequality, and we are going to go ahead and graph these. If we had taken the time, we could multiply two of the polynomials and get ourselves a trinomial and multiply it by the other binomial, and it would turn out to be x raised to the third. But in this case, we don't really have to worry about it. They're going to give them to us with parentheses. Just like when we solve for a quadratic, we take each of the parentheses and set them equal to 0. So that's what step 1 is going to be. So take each parenthesis, set them equal to 0, and find the roots. And so fairly quickly, you turn around and you find that x can equal 1, x equals -2, x equals 4. And notice in this case, we are working with less than or equal to 0. And so don't forget that equal sign. And to help you remember that, when you find where the solutions of the roots are on the x-axis, give yourself solid dots there, -2, +1, and +4. Okay, now the hard part of this is on these trinomials, you are going to start here on the left hand side. You're going to do like a roller coaster, and you're going to start up here and you're going to start going down the graph, go through -2, come back up, kind of like riding a roller coaster ride, hit the 1, and you're making a pseudograph here. The key thing is you're going to go through the interval points and you're going to finish up going down in this direction. Okay, so you're going to start up here and draw yourself a pseudograph. Doesn't matter where the highs and the lows are. The key thing is you want to cross and subdivide the x-axis. Now again, you could kind of remember that the y-axis is going through here if that helps you out. Not really necessary, but you can do it. And so what happens now is we are going to take advantage of some observations here. Notice that the b interval, I've got a little star next to here, it was 0. When you put 0 in for x, it's the easiest way to find out whether it makes the inequality true or not. And what we're going to find out is that the b relative to the y-axis is below the x-axis, and it's this component down here in the valley. And while that's down there, you come over here to section D, it also is below the valley. And so what we're going to find out here real quick here is that the intervals B and D are going to be pairs. And thus, without making the drawing too complicated, you could see that interval C is up high on the hill and above the x-axis, and again, you're going to find out that the A interval is also above high. And so we're going to get the pairings that A and C are going to be a pair along with B and D. Now the book goes through a big long hoop-de-doo operation of testing every interval, and when I studied this, I came to a starting conclusion that all you really have to do is take advantage, find where x equals 0, stick that into the 3 pairs of binomials given to you, the parentheses, and find out whether that's a true statement or not. And just keep in mind that you got to watch a negative times a positive times a negative produces a +8, and you ask yourself, is that less than or equal to 0? And you find out that it's a false statement. Now we are testing for interval B because when x equals 0, it's in the B zone, which is down below. And so what we can conclude here is from the pairings that we've had, and you can always follow this with these third degree polynomials with the 3 parentheses, that intervals A and C are going to be above. You'll notice on your hand notes, not in here, this is above the x-axis, and B and D are below the x-axis. Okay, so you can kind of remember those pairings and just test for one pair. Recommend finding wherever x equals 0. It usually is in the B, doesn't have to be, but keep the groupings together, and all of a sudden for this problem you find out that the interval that you were finding is A and C, So there's our solutions, and you look on the graph and you find that x is less than -2, and we're going to union it with x is between 1 and 4, and we're including those values. And once you see on the graph, what you got up here is the a's going this way, and then the c is between 1 and 4. I think the visual with the pseudo graph with a roller coaster ride allows you to write your solution in our union set, and then go ahead and go with the interval notation, and be careful with your parentheses and your brackets. In this case, we're including them with the numbers. Remember, with infinity and negative infinity, you always use parentheses. Okay, that concludes page 5. We're cruising pretty good here. We're going to keep moving on to page 5.5 of my class notes. We're going to do another example of third degree trinomial with a greater than 0. Okay, Mr. McCue here for now. I'll catch you in a little bit.